Hi everyone. Today we're going to be talking about standard form and scientific notation. Now, before we even begin any of this, we need to know what standard form and scientific notation are. So, standard form is a number written in its normal form. So, like 5,000, 27 million, all those zeros written out. Now, standard form is what we're used to, and it's an awesome tool. However, when you use numbers that are super, super big or very, very, very small, it's easier actually to write in scientific notation. It's actually less work. So, scientific notation is a shortened form of a very large or very small number. It's usually what you use it for. It needs to have a decimal after the first place value and then times 10 to some power at the end. So an example of this is 3.21 times 10 to the sixth power. 3 is that first number, that first place value, so that's why you have the decimal after it. It should only be one number, so there shouldn't be two digits in front. Now, I am going to split up between two videos. We're going to talk first about converting standard form to scientific notation. So, standard form again are those very large numbers or very small numbers written with all those zeros in it. So, if you have something in standard form or a number that's larger than 0, these are the steps that you're going to take. So my example right here is going to be 670,600,000. Step 1, find the decimal point at the end of the number, and this will not be written. So in numbers that are larger than 0, they don't have a decimal point, but that decimal point will technically always be at the end. If it's not written, it's at the end. Just remember that. Moving on to step 2, move the decimal in between each number until it is placed behind the first place value. So what I mean by that is if I have my number, I'm going to what I like to call bunny hop it, and I am going to move my decimal in between each number so that I have it right after that first whole number that's not 0. And now I can move on to step 3. Count the number of jumps that you move from the decimal. This will be your power. Since the number is larger than 0, our power should be positive. So again, if we have a very large number, we need a positive exponent to show that it's getting bigger. And the amount of times that I hopped was 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 hops in there, or bunny hops, jumps, whatever you want to call them. And again, the jumps are going in between each number. So this is my power. I have times 10 to the 8th power now because I had 8 bunny hops, jumps, whatever you want to call them. Step 4, write the number in between the first, or numbers in between the first number and the last non-zero number in front of times 10 to the certain power. So I have my times 10 to the 8th power. What I mean by step 4 is that you need to find all the numbers between that first number where you have before the decimal point and the last whole number that's not 0. And that is going to be 6 in this case. So I'm going to write my 6, my 7, even this 0 and this 6, but nothing else. I don't want any of these zeros after that. So my final answer is going to be 6.706 times 10 to the 8th power. That 0 in between needs to be there because it's a placeholder. It's representing something. All the zeros at the end, that is what we're trying to avoid writing. And by writing times 10 to the 8th, we will be able to show those zeros, but in a different form. Okay, now what happens if you have a number smaller than 0? Numbers smaller than 0 in this case are going to be decimals. So anything with the decimal place in front and a bunch of numbers in the back. So these are pretty similar steps, but we're going to do things a little bit differently. It says find the decimal and move it in between each number until it is behind the first non-zero number. So again, we want to find that one number that's going to go in front of our decimal point. So I found my decimal. That one's already written for us. So again, I'm going to bunny hop it, jump in between each number until I am after that first whole number that's not 0. In this case, it's going to be 3. And make sure your decimal is behind it. So again, step 2, count the amount of jumps you move the decimal. This will be your exponent. Since the original number is below 0, this power was going to be negative. So anything with decimals, or if you're starting off with the decimal, it is going to have a negative power. And we're doing that to show that it's going to be a smaller number. So I jumped 1, 2, 3, 4, 5 times, which means that my power is going to be -5. And we got one more step to go, and it says write the first non-zero number and all the numbers behind it before the times 10 to some power. So this one's a little different because all the zeros are in front. We want to avoid writing them. So we're going to find that first whole number that's not 0, which in this case is 3. And we're going to write everything after because every number after is going to be important and we need to represent that. So our number is going to be 3.01 times 10 to the -5th power, and that is our number in scientific notation. Make sure to click on the next video in order to see how we're going to do the opposite, which is taking scientific notation and converting it to standard form.